it reasonable to think that the OEM, unless he is prodded with a customer, will never change from what he has? He has no incentive.
The incentive is reliability outcomes is high profit for a company. If we can get high reliability, we're going to be a more profitable business, lower cost, more throughput. Now, companies want that. If that is being stopped by the OEM's poor quality engineering, poor quality standards, then I'm sure you're going to tell him and say, look, I'm not going to buy any more machines from you. This guy in Japan makes it better. He costs a bit more, but he makes a better machine. I'm going to go to him next time. So I'm going to give you one more chance. So that's what will happen.
But you have to do that. If you never do that to the OEM, then he does.
Look, what it's saying, the OEM's engineers are no better than anybody else's engineers. Because if their engineers understood this, they'd be out there making good quality machines to sell to you at a good price. Because that'll keep the business and make them a lot of money. But their engineers don't understand this either. Because they're setting standards that cause failure. Now, the OEM's creating a failure by setting that standard. Now, I'm sure he's not doing that on purpose to get repeat business, to buy the spare parts off him. I'm sure he's not doing that intentionally, but that's the result that your company suffers. Their lousy standards you accept as being acceptable, and it's not, but you believe it is. As a consequence, you get the breakdowns forevermore in the future. And how do you solve that? Well, you've got to have quality control. So what standards must I have? Gee whiz, give me 12. Give me 12. That will create reliability. So, Mr. Manufacturer, install on your hydraulic systems kidney filtration as part of your supply to me. If you don't install it, I'm going to install it myself. I'm going to spend the money to put kidney filtration on that unit on purpose. Because that 12 from 18 is 5 less breakdowns. That breakdown of that turbine was 2 months downtime, $25 million. That company at 18 cost that, the OEM's requirement at 18 cost the company $25 million and 2 months downtime in a power industry. They could have sold so much power in 2 months. They couldn't sell because the machine was broken. Because the OEM's requirements are nowhere near good enough. And that's what you'll find. The OEMs think wrong. They think this is low-cost machines, I'll be able to sell that, easy to make. They miss out the fact that, hey, your customer is losing a fortune because of your poor engineering standards. So I've got to have the customer understand what questions to ask. Your specifications, what is your IT grade on your components? How do you control the manufacturer of your shafts? How do you get roundness of your housings? How do I know that your bearing in that machine isn't pinched? If I pinch that bearing with an out of round housing, I'm going to have high stress in that bearing from day one. So yeah, once we know what the right questions are to ask, you will ask the right questions. And if the answer is the wrong answer, thank you very much, I'll go to somebody else next time. And you will, because there's so much money sitting on the table that is so easy to pick up. So, in terms of managing my process and sitting out and developing a process, I want to have a target for precision. I've got to have a tolerance for quality, and of course I've got to have a proof test to prove I am within the tolerance. So that's where the 3 T's come from. And I believe if we can include the 3 T's into all our tasks, into all our deliberations of what questions to ask, we're going to start hitting a lot more bullseyes, getting great results, producing processes where the outcomes are guaranteeable and repeatable no matter who does it.
You ever run into a situation where somebody says, well, we can set a target and have a tolerance, but there's really not a good test. Or the test requires me to take the equipment apart. I can't run the test.
Look, yeah, that's certainly possible. What we try and do is as the guys work through the procedure, we actually put in the tests as part of the rebuild. Because if I build a machine with 100 parts, with 200 parts, and the only test I do is at the end of the rebuild, I start the machine up and do a vibration check on the noise of the bearings. And if the test shows a high vibration within the first hour of operation, am I going to pull that machine down again and find that high vibration cause? No. I'm just going to say, oh, guess what? We've rebuilt this incorrectly, but run it anyway. I haven't got time to rebuild it. So these tests have to be done during the actual process of rebuild. We're going to have hold points to do inspections and measurements against a particular standard that we have chosen. So we're going to have a test throughout that whole rebuild process. Operations throughout the operating process, we should have test points. What are the pressures, what are the flows, what are the currents being drawn by the motors? Are they within the boundary that gives us high reliability? So the 3 T's is a principle. It's a universal principle because it's going to create a process of very tight outcomes. And it's the accuracy, the quality control that drives reliability, that produces the outputs that deliver the high performance and high profitability that we're looking for. It's a different way to think. It's demanding. It's more demanding, no doubt about it. Guys have to be guys that can deliver this level of quality. It might require some upskilling or some reskilling. We have to buy some smart technology. We have to buy some stuff that lets us test things easier and simpler and faster, intentionally, so we can be sure that we create the results that we want. So yeah, there'll be times when it will not be easy to do, and we're going to have to find a way to solve it, or at least be comfortable that what's being done is acceptable. But it won't be necessarily easy to do every single time. But the way to think is the right way to think. Yeah, so we're going to have good is